So I just stumbled upon this wild concept about the functor hierarchy in Rust. It's a whole other universe compared to Haskell.
Right? Like Rust has these fine-grained traits like functor and monad, but they don't quite hit the sweet spot we get in Haskell.
Exactly. It's fascinating how Rust's functions feel less first class from the type system's perspective. That really complicates things.
Oh, for sure. And that type constraint headache when trying to implement functor for something like hashset, that's a real head-scratcher.
Wait, seriously, you can't apply functor to hashset? I had no idea.
Yeah, because the bounds on the type arguments get restrictive. It's like you have to jump through hoops just to implement fmap.
So what did they do? Just gave up on it?
Not quite. They created this hierarchical structure with traits like applicative and bind, but with limitations.
This puts them in a weird spot, huh? Almost like Rust is capable of doing it, but on a frustratingly limited scale.
Totally. And it led to some really convoluted type signatures too, all in the name of trying to maintain some type safety.
Ha! Kind of like Rust's way of saying, sure, you can have this, but good luck with that.
Exactly. But here's the kicker. Generic associated types actually help achieve a subset of what higher-kinded types do.
Oh wow, that's surprising. So there's a silver lining in all this complexity?
For sure. It's like they found a creative workaround, but it still doesn't fully replicate the elegance of Haskell's system.
I'm trying to picture this whole implementation in my head. It's a lot of juggling, huh?
Definitely. Implementing abstractions like bind can get complicated really quick, especially when type inference trips you up.
What's this I hear about needing stricter bounds? Please tell me there's a simple fix.
Unfortunately, no. It requires adding extra constraints, and sometimes the type checker just can't keep up.
That's kind of counterintuitive. You'd expect the type checker to handle this, right?
Exactly. The type checker should be smarter about it. It's frustrating to see such an oversight.
And to think they had to create a run macro for Haskell-style do notation. That's a funny workaround.
Yeah, that was a clever approach, but opting for run instead of do, due to reserved keywords, is just a classic Rust struggle.
That's rich. It's like Rust is both giving and taking away at the same time. What a balancing act.
For real. And even with these traits, there's still a gap. So much complexity for something that seems simpler, you know?
I get it. It's like when you think you're climbing a simple hill, but suddenly you find there's a mountain right behind it.
Exactly. And this makes Rust feel less functional. It's like you're dancing around the constraints all the time.
This really makes me question whether the functor hierarchy is worth all the trouble. Is it even useful?
Well, it's more of an exercise in exploring Rust's capabilities than a practical implementation, for sure.
It's like saying, look what I can do, while knowing full well it's not suitable for everyday use.
Yeah. And that makes you think twice about whether Rust is ready for a proper functional paradigm.
So is there hope for constraint kinds in Rust's future, at least?
I think so. There's definitely a need for it beyond just this functor hierarchy.
That's a glimmer of hope, but wow, what an uphill battle this whole journey has been.
It really has, but it's also exciting to see how Rust evolves and where it might go next.
Definitely. This makes you appreciate how language design can impact developer experience.
Exactly. And how sometimes even good intentions end up creating more complexities than solutions.
If anything, it's a case study in the trade-offs between safety and simplicity in programming languages.
Absolutely. And at the end of the day, we're all just trying to make sense of these abstractions.
Right? This makes me wonder, what else might be lurking in Rust that we haven't uncovered yet?
Oh, there's probably a treasure trove of gems waiting to be discovered if we dig deep enough.
That's such an exciting thought. So much to explore, so little time.
Exactly. And this conversation really had me reflecting on how adaptable we need to be as developers.
Totally. This is a reminder that every language has its quirks and complexities, but there's beauty in that.
Well said. Here's to embracing those complexities and making the most of them as we learn.